Okay, so we've got the segment HG. We're supposed to find a midpoint. I'm not going to worry about this formula up here. It's much easier than that. What you want to do on both G and H is break it apart into an XY problem. Think about the X's and Y's separately. So I'm just going to go ahead and write these coordinates down so I can refer to them. So let's look at the X's. The X coordinate of H is -5. The X coordinate of G is 7. We're looking for the midpoint. So I want the number that's right in the middle of those two. So if I want to be right in the middle of those two, I want to find their average. You guys know how to find average? That's all this formula, this stupid formula over here is. It's just averages. So I want to average the X's. So -5 and 7. I guess they're called the midpoint P. Sorry, I don't know why I said -1. -5 and 7. If we're going to average them, it means add them together, divide by 2. So add those together. -5 plus 7 is 2. Divided by 2 is 1. And then for the Y's, take a look at the Y's. We've got -6 and we have -2. Add those together. And we get a -6 and -2 adds to -8. And half of -8 is -4. So 1/4 is the midpoint of that segment. Now number 4, it's kind of going backwards from that because you'll see that they give us an endpoint and a midpoint. Instead of giving us both endpoints like on the last one, we know the midpoint this time. So we have to kind of work backwards. So I'll sketch a little picture. There's W, midpoint is right here. And understand, we don't know the other endpoint. The other endpoint is V. It's asking about segment VW. We don't know where V is. But we know that M is in the middle of it. So if I start up at W and I try to draw a segment, I go through M and I have to keep going, and somewhere over on the end of that is V. I don't know where exactly at this point. That's what I have to try to figure out. So the best way to do this, once again, let me write down the ordered pairs, have them right here close, 4, 4. And then the midpoint is -1, -2. The best way to do this is to think of the X's and the Y's separately. So we know that when we look at X's, we know -1 is in the middle. Middle of what? Well, the middle of 4 and something else. I think the best way to find that is to start at the endpoint, start at 4, and think about how far we have to go to get to -1, because -1's in the middle. So I start, and I'm not worried about Y's, I'm just looking at X's. So I start at 4 and I go to -1. That means I went to the left 5 units. To get from 4 to -1 is 5 units. That was halfway. So to get to the other endpoint, I have to go 5 units beyond that. So I'm here at -1. I want to move 5 units to the left. -1 minus 5 is -6. That gives me that endpoint. Then I look at the Y's. So start at W, the endpoint, it's 4. At the midpoint, we're at -2. So we start up at 4 and we go down to -2. To go from +4 to -2, I went 6 units. So I have to go 6 more units. So -2 and go down 6, that's -8. So now I know the endpoint. That would put it somewhere down here, which makes sense. Now let's look at the back. So they changed gears. They're no longer talking about midpoint. They're talking about length of an entire segment. And nowhere on the notes here is there a place where it talks about the length of a segment or a distance between 2 points. If you look in the textbook, at this point they'll talk about the distance formula. And the distance formula is a really ugly formula if you're going to memorize it. It even uses a square root. And once again, I propose not using that formula. I don't think it's a very nice one. So instead, let me show you a better way. That formula comes from the Pythagorean theorem, and you should already know the Pythagorean theorem A squared plus B squared equals C squared. And we're just going to turn this into a Pythagorean theorem problem. Pythagorean theorem is used on right triangles. So I'm going to take this picture on number 5, I'm going to turn it into a right triangle. To do that, I need to draw horizontal and vertical connections to get from R to S. So it doesn't matter if you start at R or start at S. There's two different triangles. They would give you the same result. I'll start down here at R. And I'm going to connect horizontally until I'm right below the S. So right there. Now I'm going to go vertically to get up to the S. Horizontal and vertical are perpendicular to one another, so I just created a right triangle. When things are horizontal or vertical, you can count how long they are. When they're diagonal, you cannot. So I can't count the length straight from R to S, but I can count over. So I started at R, I went 2 to the right, so that distance right there is 2. And then I went up, and we can count at 1, 2, 3, 4, 5 units. So I went up 5. So I have a right triangle, and I know the two legs, and I'm trying to find the hypotenuse. I'm trying to find SR. Maybe. When we're thinking A, B, and C for our Pythagorean theorem, C has to be the hypotenuse. That's the longest one. That's the C up here. The two sides that make the right angle, those are your A and B. It doesn't matter which one's which. So let's do Pythagorean theorem. 2 and 5 are the A and the B. So we're going to square them both, add them together, and it's equal to C squared. So let's square 2. You get 4. When you square 5, you get 25. 4 plus 25 is 29. Then to solve for C, we square root. Hopefully you remember from algebra that when you square root to solve an equation, you need to remember plus minus, because there's actually two answers to the problem. However, now that we're in geometry, we realize that C here is talking about a distance. It's the length of a side of a triangle. And we know that distances cannot ever be negative. They always have to be positive. And since this is measuring a distance, I don't want the negative one. I only want the positive one. Because that's true, a lot of times in geometry, we don't even write plus minus. Now, that works well in geometry. It doesn't work so well when you're in Algebra 2 next year. So we'll try to periodically throughout the year as we're doing these remind you that, hey, really there is a plus minus. It's just that in geometry, we only want the positive one. Okay, so now at this point, square root of 29, a lot of you, I assume, would pull out the calculator, type in square root of 29, and see what you get. And what you're going to get is a decimal that goes on forever. Now, the calculator will stop it at some point, it will round it. But really, the decimal goes on forever, and it doesn't repeat. Because of that, there's no way to exactly write it as a decimal. You have to round it. We're getting into a high enough level of math now that we don't like to round things very often. So I don't want you to plug that in your calculator and get a decimal. What I want you to do is actually much easier than that. The answer to this is just square root of 29. That was the answer. That's the only way to exactly represent that length. And there's nothing wrong with expressing it that way. Now, if you have to cut a piece of, a board, square root of 29 inches, that doesn't help you much. Then you'll want to convert it to decimal so you know about what to do. But unless that's happening, we like the exact answers. I would also say, though, be careful. If you get like square root of 25, don't leave that as square root of 25. The square root of 25 is equal to 5. You should simplify it then. But this one doesn't simplify. It's just square root of 29. Okay, moving on. Let's take a look at number 6. 2, 5 is A. So we go 2 to the right and then up 5. 1, 2, 3, 4, 5. And B is negative 4, 8. And they want us to find the length of that from A to B. So once again, I'm going to draw a right triangle. No, there are two right triangles you can draw. You can draw that one, or I could have started at B and went to the right and then down. But they're both going to be the same. So now as I look at this picture, look at the vertical piece. I went down 1, 2, 3 units. Look at the horizontal piece. I went 1, 2, 3, 4, 5, 6 units. So 3 and 6 are my A and my B on this right triangle. So 3 and 6, 3 squared and 6 squared. 3 squared is 9, 6 squared is 36. Those add together to make 45. Then I square root. So now I've got square root of 45. Square root of 45 does not turn into an integer. Square root of 49 does, but square root of 45 doesn't. But this one can be simplified. A little different than square root of 29. I skipped over it because I didn't do it. But square root of 45 can be simplified because it has a factor that's a perfect square. What I think is the best way to simplify square roots is to make a factor tree. So let me show you how we make a factor tree on this and then determine how to simplify it. So let's do a factor tree on 45. 45, you can break it down into like 5 times 9. 5 is prime, it doesn't go down any further, but 9 goes to 3 and 3. What we're looking for when we simplify square roots, we're trying to see if there's a number that shows up twice, so that shows up in a pair. So what I got was a 5, a 3, a 3. I ignore the 9 because I broke it down. I ignore the 45 because I broke it down. I only look at the bottom branches. A 5, a 3, and a 3. I'm looking to see if there's any pairs. There is. There's a pair of 3s. When I see a pair of 3s, I like to circle it. Now, what I do then for my answer, be careful because I'm not going to write 9 down and I'm going to lose one of the 3s. I want you to understand why. Realize that 3 times 3 is 9, and I'm taking the square root. The square root of 9 is just 3. A regular 3 that's not inside of a square root. So when I end up with a pair of 3s inside of a square root, I can get rid of the pair of 3s on the inside and put just a single 3 on the outside. Now there was a 5 still on the inside. It was not paired, so it does not get to come out. So it stays on the inside. So you got to pull a 3 out, the 5 got stuck in there. That's your answer. So it's an exact answer. It's not rounded, but that one did simplify, just didn't simplify all the way down to an integer. So the answer to that problem is 3 squared root of 45. All right, then your assignment is right here at the bottom. It is out of the textbook. Since you don't have accounts set up for the textbook yet, because we don't have those activation links, I have put, I've taken screenshots from my computer of each of those problems and put them on Canvas. So you'll be able to find that assignment right there on Canvas.